So once the packet gets out to the bigger internet, now the internet routers have to figure out how to get this packet closer to its destination. And what that means is that all of the routers on the internet have to coordinate with each other to figure out where all of the destinations are. And this is a problem called routing. It's a pretty involved topic that we're not going to get too far into, but just to give you the highlights, the internet is a network of networks. That's something we've talked about before. You have all these local networks, and they're all connected together to form a global network. That's the main idea behind the internet. Now, in routing protocols, these individual local networks have a name. They call them autonomous systems for reasons that we won't talk about. But you can just think of an autonomous system as one of those local networks. So in the analogy, each apartment complex might be an autonomous system. In real life, UC Berkeley could be one autonomous system, and Stanford could be a second autonomous system. And somehow, all of these individual networks, these autonomous systems, have to communicate between each other to find paths through the network. So if I'm only working by myself as my own apartment complex, how do I know where everyone else is located? I don't. I have to talk to other post offices or other autonomous systems to understand where anybody is located so that I can forward packets in the correct direction. And BGP is the protocol that allows all of these networks to talk to each other to achieve connectivity and understand where to forward packets. So this is a simplified model of what BGP looks like. If you're interested, you can go check out CS 168 at UC Berkeley. They have like 2 full-length lectures on this topic, but we'll talk about it in like 10 minutes, so it's quite simplified. But in real life, you could imagine this is my network of networks. It's quite simplified, but within each of these networks is a bunch of computers. So for example, this could be UC Berkeley, and this could be Stanford's network, and each of these could be one apartment complex in our analogy, and they're all connected by some sequence of routers. So as of now, nobody knows where the sender or the recipient are. You can imagine no one really knows anything. If you're this post office, you don't really know what's to your left, what's to your right. So what these autonomous systems have to do is communicate with each other to learn where things are located. So for example, one way this might happen is for everyone to advertise information about who they're connected to. So for example, AS6 over here might say, I am directly connected to the recipient. That's a useful piece of information. And what it can do is send this piece of information to all of its neighbors. So AS6 can tell 5 and 4 and say, if either of you ever have information you want to send to the recipient, you can send it to me, and I'm directly connected, so I will forward it for you. That's a piece of information that 6 can tell 5 and 4. It can say, I'm connected to the recipient, so if you have data for the recipient, send it to me, and I will forward it along for you. So now 5 and 4 both know if I ever have data for the recipient, I should send it to number 6, and they will forward it for me. That's a useful piece of information. Now, because 5 now knows how to reach the recipient, it can also tell some of its neighbors about this new piece of information. And likewise, 4 knows a new way to reach the recipient, so it can also tell its neighbors about this new interesting fact. So 5 and 4 can go and tell their neighbors and say, I'm number 5, and if you ever want to reach the recipient, send packets to me, number 5, and I will send it to 6, and they will send it to the recipient. So if 5 tells this fact to 3, 3 now knows if I ever have packets for the recipient, I will send them to 5, they will send it to 6, 6 will send it to the recipient. It's a useful piece of knowledge that 3 now knows. So 3 knows how to forward packets to the recipient. They don't go this way, they go this way instead. And likewise, 4 might be able to tell 2 and say, I can reach the recipient. And so now 2 knows if I want to reach the recipient, I will send the packet to 4, they will send it to 6, 6 will send it to the recipient. And eventually 1 also hears some of this information, and 1 learns if I want to send messages to the recipient, I can send them to 4, they will send it to 6, 6 will send it to the recipient. So this is a very high-level picture of BGP, There's a lot of little intricacies that have to do with what happens if you receive 2 routes, how do you tie break, what happens if the network changes. We're not going to go into any of that. All you have to know is that the way they exchange routes is by advertising this information to their neighbors. And as this information spreads across the graph, everyone eventually learns how to reach the recipient. So even someone as far away as 1 now knows if I want to reach the recipient, I will send it to 4, who will send it to 6, who will send it to the recipient.